Sometimes I wonder what this city looked like before all this. Probably like many others. People had their ambitions, plans, goodbyes. Now it's all gone. The virus started it, but it was the people who made the world the way it is. This city, Villedor. They tell me they had a vision. They had hope. But soon, one vision broke into many different ones. Instead of fighting together, people stood against each other. War broke out.
Wasn't a little bird, lit a broken leg.
Hope died. Now the city is falling.
These times strike down an enemy. We absorb their strength.
But I can't let that happen. At least, not yet. I need the secrets the city holds.
Fuck. Hey! Still some birds here.
I have to take a side.
But there's not any good people. You're doing great so far.
I have to make a difference.
Let's check and see.
They say that great change is a series of small gestures. How about this series? There's all hope, Villedor. We'll see about that.
Hi everyone, my name is Łukasz Burdka, I'm from TECHLAND, and today I'm going to tell you about City Builder, a tool that created Villedor. So, before we start, first question, who knows what Villedor is? Let's see your hands. Okay, what is it?
It is a city in Dying Light 2.
Great, and he's not from TECHLAND, it wasn't staged. Now, what if I told you that this city was generated? Let's hear about that. So first, let me introduce myself so that you know who your host is today. I've been working in TECHLAND for 8 years now, and I worked on Dying Light the Following, and Dying Light 2 Stay Human, of course. I'm currently a lead technology programmer and I'm a part of the engine team. I specialize in world building technology and I'm the architect of the titular City Builder. The plan for this presentation is as follows. First, I will start by telling you in general what the titular City Builder is. Then I will provide you with the genesis of this tool and tell you why we needed it in the first place. Next, I will explain our workflow of building the game world that we used in Dying Light 2. And next we'll take a look under the hood and see how the generation I mentioned worked in this pipeline. Finally, I will tell you my insight about the lessons that we learned during all this process of developing the tool and the game using it. The presentation covers a rather broad subject, so I consider it as an overview of our approach. Okay, so first, what is City Builder? It's a very generically named toolset used for creating a game world. And in case of Dying Light 2, this world was the city, hence the City Builder. And of course it was meant to be a working title, but it stayed because no one came up with anything better. But what is it really? So first, City Builder is a top-down planner. So it is a tool that gives users a 2D overview of the game map and lets them create it from a urbanist perspective by creating a network of roads and first doing it on a very coarse level and then getting into details as the development progresses. It is also a content generator. So the plan is procedurally filled, modified by users and then generated to place some content on the map. Then it, of course, can be iterated. Different types of generations could be applied. So City Builder places this generated content on the level and hence creates the map. Because it places all those objects on the level, it's also responsible for the organization of the game object hierarchy. And it also optimizes it for the open world streaming, because we want to make a huge open world game using this technology. And for the same reason, it is also an LOD generator, because it places content on the map, so it also generates LODs for them, so that we can have a seamless open world streaming available. Okay, so now that you have some idea what City Builder might be, let's see the genesis, why we even needed such a tool in the first place. So this video demonstrates the scale of our open world, from a very small detail of interior like a pickle jar to a view that the player sees when roaming the outdoor, to a really large-scale bird-eye view that overviews the whole scenery of the city. But it's not really the area of the map that's impressive, in my opinion, but the amount of objects that we packed there and how densely this space is occupied. You just saw one of those buildings, you can't even see it from here, and you can see how many of those buildings are placed in the city. And almost each one of them has some kind of interior, something to look inside, something to find. So we had like a really densely packed space. But, you know, this is the shape of the city. It's like the 3 main playable zones. This is the city that is available right now. And I think building it was quite an ambitious task. But as if with many open world AAA games, our initial ambitions were even larger. The primary size of the city that we expected was something like that, with those red zones as well. So it was expected to be about 3 times bigger than what we ended up with. So, you know, we knew that the city is going to be big. And we did the math. We calculated the number of buildings that would exist in such city. We estimated the time needed to build each building manually and place it on the map. And we knew that we definitely couldn't do it in any reasonable time, and especially not in the time we wanted to invest in the development of the game. Then we asked ourselves a question: what if we wanted to change something? In a space as densely packed as you can see here, even a small change triggers a chain reaction of changes. We remembered a story from Dying Light 1 where moving a single street in Old Town, just a couple of meters, took 2 months of the whole development team responsible for this map, because we didn't have any solutions for fast iterating with the shape of the city. And the amount of loose objects that needed to be readjusted, holes to be patched, was just so huge that this task was tedious, just to move one street a couple of meters. So we knew that we need to avoid this if we are to build a large city. And, you know, we expected some changes, but I'll just give you some idea of what the changes actually were. So this is the initial shape of the city. You can see it has quite many districts, diverse districts. We started implementing it, drawing those shapes. I think we already had the network of streets. But then after some time, it was changed into another shape of the city. something like that. Then after many iterations, it got simplified to something like that, which after a year or something was changed to this shape, which after iterations, many iterations, became the final shape of the city. And you can see this is the render from the city builder plan after the game released. So this is what we ended up with. So I think that now you understand that the scope of the game was ambitious from the very start and ended up being quite ambitious as well. And you understand our reality of making changes. And of course, these changes were done to assure the best quality of the final experience, but we needed some way, some tools to make iterating with it effective in any way. Enter City Builder. So, now that you understand why we needed this tool, please let me tell you how we used it to create the Villedor. And to be honest, our workflow evolved quite seriously during the development process, and I think that this evolution would be quite a good topic for another presentation, but for now I will just show you what we ended up with, what was our final workflow, which I think was quite effective. It was like a result of many iterations we had during the development. So, as I mentioned, I will get into details of how the generation works later, but one important concept to keep in mind during this talk is that we generate the city from the plan. So over and over again, like a couple of times during the day, repeatedly, the map is cleared from all assets and then regenerated by City Builder based on the plan. Artists modify it and then it gets regenerated. It's like a constant repetitive process. Okay, so City Builder needs to create the map based on something. That's why it needs some input data, of course. These input data are building blocks that are placed on the city, configuration scripts that tell City Builder how those building blocks should be used, and the city plan that, well, you saw what is a city plan. It's just a plan that tells what goes where, basically, and how the city, specific city should be built. In C Engine, our building blocks are called prefabs. And prefabs are like hierarchical structures of assets that can be dragged from the browser and placed on the map by artists. Only in case of our workflow, they are not really placed on the map by artists, they are placed there by City Builder. So prefabs that need to be prepared in order to populate the city are generic buildings, which are like the regular tenements that you see everywhere, like gray buildings, nothing special about them. Then road segments that form the road networks in the city, crossroads that are used to connect them, nature biomes, which are used to like populate the natural areas or just fill the backyards with debris. And of course, unique locations as well, because just a city like that would be quite boring. So a prefab, an exemplary prefab of the building, like generic building, is something like that. You can see the part of its object hierarchy in the window, right on the right. And this is something that artists and level designers created as an input data for the City Builder. Our prefabs are also, they can be very generic and can be configurable. So when you see a building like that, I guess you can't see the writings, but the writing on the wall says pick different skin is because this building can be configured to have many different visual styles, even though it is just like one prefab. So our prefabs can have like different variants of them. They can have also some randomized elements like randomized gameplay, helpers, or like anything level designers invent. Then those building blocks, those prefabs, need to be listed and described in scripts so that City Builder knows how to use them. And we have different types of scripts. We have scripts for buildings that will tell how to create buildings. We have scripts for roads, scripts for road decors, which are like decorations placed along the roads. We have another scripts for crossroads, for connectors between buildings, and for biomes. So apart from making the prefabs, level designers and level artists also had to create some scripts to fit the system so that it knows how to create the map using them. Now, building scripts is like the most commonly used one in the city. It can be the most complex ones. And in the initial iterations, we try to heavily generate the buildings to have many different variants of them. So the content creators really were preparing only the parts of the buildings that then City Builder assembled into buildings. But we diverted from this approach, and in case of small buildings like that, we tried to keep it as simple as possible to keep the entry level of scripting those buildings as low as possible, because some level designers were really traumatized with having to script everything. So, like in a very basic example, the building in a building script must have an 2D shape outline that says like how big it is on a plan, and some layers defined. Layers are prefabs that are placed one on top of each other. And in case of low buildings, they were just 2 layers, like the main building structure that you see just a moment ago, and the parkour shapes on the rooftop. So a single building could have different parkour variants on the rooftop to differentiate the gameplay there. But of course, buildings can also have some more complex features, like they can have defined parts that can be modified. For example, this building could have in its script defined that it can have a shop on the bottom, or that it can have accessible interior or not. It is something that was created and annotated in the script. So building scripts. We have 2 types of buildings. One of them is just regular straight building that is placed along the road, and another one is what we call a corner. So corners are buildings that cover an angle that are placed between exits of crossroad. Like this, what you see here is the corner of 90 degrees. Then we have road scripts, and in road scripts we have 2 types of roads. One of them are like generated geometry. It's generated based on splines, curves, and based on just like a small profile mesh. And we have roads that are built from segments that are just placed one after another in a straight line. So this way, level designers can prepare like larger segments, and then they can be just placed one after another to create a road. Every road needs to have a size, I mean the width, so that the crossroads know how to connect to them. And then we have decor scripts, road decor scripts, and these are the objects that are placed along the roads to make them more interesting, to make them more decorated. They can be like street lamps, some trash bins, or other like objects that are just scattered along the line. They can be virtually anything that is placed on the road and can be in some regular sequence. They can be also randomized. They can be scripted to be like, first there should be this sequence of cars, then another one, then a trash truck, and then some randomization. So those decors can really be scripted into something that creates large variety of road decorations, so that you don't see 2 roads that look like similar too much. And also to break the regularity of the lanterns, for example, you can define that one of every 3 lanterns should be like modified somehow or different. Then we have crossroad scripts, and crossroads are really simple in the definition. They just need to define how many exits a crossroad has, and angles between each consecutive exit, and the width of an exit so that we know that we can use it to connect roads of certain widths. And if we want to have like a transition between two different sizes of roads, we also need a crossroad mesh for that, even though it has just like 2 exits. But it's used on nodes like this one, for example, to just connect them. This one was actually used as an entrance to the park as well. So these are crossroads. There are many types of crossroads defined in this script. Then there are connectors, and connectors are a special type of scripts that we found out that we really need in order to make the parkour smooth. So connectors are objects that are connecting suitable points on generated geometry. So the buildings can have helpers that say that those places are suitable for certain types of connector, and then the connector script defined what can go there. So in this case of this bridge that you see, we have like a start and an end of this bridge that are generated in places where normally there is just like a small helper on the building. And there is also another prefab defined that is stretched between them. It is the bridge prefab inside. And those connector scripts have parameters like you must provide an acceptable angle for every connector, because if it's a bridge, it needs to be rather flat, but if it's a zipline, then it must have a certain angle. And then acceptable distances that we can stretch the connector across. And finally, there are biome scripts. So our biomes were rather simple because we were just making a city, not a very complex, open, natural environment. So our biomes just defined prefabs that have the top and bottom radius so that they don't intersect each other, some priority, and the type of ground that they can grow on. And this was rather simple but sufficient to populate our city. And finally, there are unique locations, but they are not listed in any scripts because they are just manually placed on the city plan by level designers and level artists. So unique locations need to have just 2 requirements. One is they need to have a unique name. And another one is that they need to have some sort of like 2D outline shape to tell City Builder how much space they occupy, so that City Builder knows how to build content around them and not like penetrate them with some generated content. So the first step of using all those scripts and prefabs to build a city is by drawing a road network. So users does this by placing nodes manually on the map, and then those nodes are connected by the user, forming edges, and in closed loops of those edges, areas are created automatically. So we have nodes, edges, and areas as types of items in City Builder. This forms what is called a planar graph. So we have nodes connected to each other in such a form that they form closed loops, which are areas. This is a planar graph. This plan can also have logical layers, so we can have multiple graphs like laid on top of each other. Those layers can be shown or hidden as users see fit. And it was useful for creating like logical areas, for example, like some ambient zones or influence zones defined or other layers that can be totally independent from the road network, but they can still be like the part of the same plan. When you look at it, you can imagine probably that this represents a city plan. But such a structure created from nodes, edges, areas is just an abstract graph. What really makes it a city plan are generators that are assigned to those plan items. So each node, edge, or area can have a generator assigned, or actually multiple generators. So they are what gives meaning to those elements. So edges can not only be roads, but they can also have a generator that would create a wall or a fence or a harbor line using them, or generate virtually anything that can be placed along a line or a curve, because edges can also be curved. Nodes are usually just crossroads, but they can also be used to place a single generic buildings in a certain place where they are located. And areas, they have like the most vast usages, because they can be used, of course, to be populated with buildings and vegetation inside. But also they can be used to generate spawn points randomly in an area for the infected. Or to create any volume, like the logical volume, for example, an ambient zone that would play music when you enter it, or some gameplay modification area, or something that would change the color grading when you enter it. Like, there are really tons of usages for that. Whenever you think of something that you want in game that has a polygon shape, you can use area for that. Then what makes the game really interesting and like not plain generic one are unique locations. And in City Builder, in our system, we called them pinlocks in short, because they are objects that are pinned to the plan and then lock part of the plan from generation, hence pinlocks. So pinlocks are those green shapes, the dark green shapes that you can see on the map. We have actually quite a lot of them, and they represent unique locations. They can be like big structures like a church or hospital, or they can be just some situation with a couple of NPCs and some logic binding them that was like handcrafted in a certain place. When pinlocks are created, they are pinned to the plan to indicate where there should be and how much space they take. And the crucial thing about pinlocks is that they always occupy some certain space. So, for example, this church is there. You can see the extents of its prefab. So, you know, everything is inside it. And it is really useful because it allows us to move a pinlock from one place to another, and then everything that we have inside will move with them. So all quest logic, quest items will move with it. Which is like something else than we had in Dying Light, where level designers would just place all items in huge prefabs scattered across the map, and then if you wanted to move like a building, it was leaving a ton of loose objects behind, because they were not organized neatly in a hierarchy. So this approach was kind of forcing them to organize it in such a way that it can be moved around. Pinlocks can also have several states in what we call switchers. So a pinlock can have different variants. For example, a skyscraper could be like a regular skyscraper we see on the left, and then a bombed one on the right. And they both are generated, and then they can be switched in runtime by our story system as pleased. And it is like a distinctive feature of pinlocks as well. The city plan can also be divided into regions, and it should be divided into regions for two reasons. First one is that it allows multiple people to work on the map on the same time. So, one user can work on the city plan and move the edges, assign attributes in a single region at the same time. But if we have multiple regions, then they produce different files, and they are independent from each other, so users can modify them independently. And also another important reason is the resource management in the game. So we only load assets and meshes and like everything we need into the memory for the region we're in, and its surrounding buffer zones. The buffer zones are what we see as green zones here. So this allows like seamless transition between regions, and provided that we give like enough time to the console hardware to load the region we're going to, and to unload the region we're going out of. So regions are used for resource management as well. And this way we are not constrained as much by the console memory because we can bundle the assets together. Now, at this stage, we can really freely iterate with the shape of the city. We can move nodes, we can assign attributes. If we add some new building, it will get populated all over the city. If we change some nodes or move them, the city plan adjusts to that. So it's like really flexible. We have those iterations possible that we wanted. And we can just iterate and iterate and iterate, like we did. But at some point, we want to start locking the shape of the city so that some adventure can be directed in it. We want to have something for granted, like maybe this street won't be in a different place tomorrow because someone decided so. And that's the place where persisting of the plan comes to play. So if we persist a single area, what happens is that City Builder no longer designs how the buildings are placed inside it. It just treats the state that was persisted as an accepted one, and it gives level designers the possibility to just click on buildings and change their parameters, change their variants, or just it moves them from the level of designing a district to a level of designing an area. So if level designer thinks like, I need a different variant of a roof in this certain place, they can click a building and change the variant of the roof. If they want to add shop on the bottom, they can do it. They can switch buildings with places in an area, or replace two small buildings with one larger one. So that's the amount of control they get once they persist an area. And of course, the plan is still a bit flexible at this point. So if you just move an edge, then City Builder will try to keep the sequence and the order that was in the persisted area as much as is possible, provided there is place for that, of course. Yeah. So iteration is still possible. Up until the moment we freeze the content. So freezing is like the final stage of the creation process. So the plan is no longer flexible around frozen areas. This gives the level designers the ability to tweak no longer buildings, but already generated prefabs, and do some stuff like enviro storytelling, like modifying prefabs in a certain place so that they are a bit more unique, adding yellow planks to guide the player in certain places. So really those small manual changes are available at this point. And it's not necessary to finish the game, but it definitely makes those finishing touches much easier. And at the end of the production, we actually had the whole map frozen because we wanted to avoid a situation that we changed something in the generation pipeline or method, and it would just change the way buildings are located. Because, I don't know, we change a random generator or something, and then we would have another set of buildings another day. So we wanted the city to be exactly the same with every patch, and only make manual changes. That's why we frozen it, the whole city. So now that we have some idea what our workflow was, let's take a look under the hood and see how the generation pipeline worked, how we actually generated the city this way. So let's see what happens on a builder machine that produces the map for everyone to play. First, all assets are cleared from the map, and only the terrain is left and some illegal assets that are placed there by level designers outside of the city builder object hierarchy, because they wanted to avoid the generation pipeline. Then the plan is loaded and it starts to be arranged. So at this point, City Builder tries to figure out what goes where. So nodes select the crossroads that should go there based on the roads around it. Roads assign decor sequences to them. Those are the shapes you can see, the colorful ones. And the areas arrange buildings along the roads so that there are no holes between them and, well, respecting the rules that are given for a certain area. But at this point, nothing is generated, no content is created. It's just everything on the plan. User can click stuff there, can modify things on the plan, but nothing is on the map. Then the pre-generation happens, and pre-generation is the process in which City Builder figures out which prefab should be in which place on the map and what sort of configuration should it have. Still, nothing is generated at this point. It's just determining the positions and like positions for every part of the building, like for every layer. Then nature generators figure out position for every tree and bush. You know, spawn point generators figure out where to place every spawn point, and so on. And then the generation happens, which is prefabs are actually placed on the map and organized into prefab hierarchy. Yeah, and at this point, the on-generation code and logic also applies. So the generated objects have a chance to check the collision detection, for example, and see if they don't intersect any other generated objects, or they can get aligned to the terrain if they need so, or check some conditions and change some of their attributes based on other objects that are around. And there's always a link between the generated content and the area that generated them, stored in the prefab metadata. So if a user would like to just regenerate a single area, then this generated content for this area would first be cleaned and then regenerated. So this way, like iterating locally is also possible. Now, in theory, in this stage, the game could run and you could see the content placed on the map. But it definitely wouldn't load on any consoles and wouldn't run smoothly on PCs even, because the source hierarchy of prefabs is not meant to be used in the game because it's too heavy, has too many entities. So that's why City Builder optimizes the content it generates. And the optimization does several things. One of them is collapsing the hierarchy so that only the leaf entities are left there, ones that cannot be collapsed deeper. So the ones that, for example, have references from the story system or among each other, or just are logical gameplay entities that cannot be collapsed. But the whole prefab hierarchy is collapsed. Also, any editor-only helpers and objects that are meant to be only in the editor are completely removed from the hierarchy to not occupy any memory. And entities disabled by collision detection, for example, or by any other condition are also removed from there so that they don't occupy any memory at all. And at this point, it's also important to introduce a concept of spawn types that we have in our source prefabs. So every prefab, every mesh can be either exterior detail, interior or interior detail. You can see they are marked by those colors. Green is exterior, this cyan is exterior detail, and yellow is interior, and red is interior detail. And they are bundled together into a really optimized form of rendering. So all meshes for exterior are bundled into an exterior simple bundle, and all those meshes, the single meshes, are also removed from the hierarchy and are replaced by their optimized version. Then all objects sharing the same spawn type are grouped together under a spawner so that they can be spawned and despawned in the game. Of course, this process is meant to be invisible normally, so I had to tweak the ranges and parameters so that you can observe it. You can see that the different elements, like the ornaments on the building, appear right now. And then some interior elements right now, and then interior details elements now. So the spawnification process is what just really creates those assets in the game as we traverse the open world environment. But if it wasn't for the next step, LOD generation, we would end up with just an environment that's rendered 70 meters away from the player, and then the blank space where stuff goes despawned. So that's why we need the LOD generation as well. We tried many different approaches to LOD generation. It's a subject for entirely separate presentation, but in the overview, what we ended up with was an approach where artists prepare like simple meshes, LOD meshes, for any part of the prefab hierarchy they see fit. So for example, if there is a roof created from many small meshes, they can create like a LOD mesh for it. Then if there are many chimneys on it, each one of them can have also its LOD mesh prepared. And then City Builder gathers all of them together and creates like a glued together simplified geometry from those meshes. What's really like boosting the performance of creating this content here is the fact that they don't need to texture them because it is something that is done by the City Builder. So I mentioned before that we can persist content. So you might wonder where this persisting fits into this generation pipeline. So what happens for persisted content is that we simply skip the arrange phase for the persisted areas, and we treat building data stored in the plan as if it was just arranged by the City Builder. And well, this way the pipeline goes like the same way, but we treat the stored data as generated one, arranged one. And in case of frozen content, we use the same logic, only when the area is frozen, the prefabs that were generated are stored in our version control system as source ones, so they can be modified by users. There is always a link between the area and the source prefabs, so that when they are modified, City Builder still knows which one of them should be used in which area. And the arrangement, pre-generation, and generation phases are skipped here, and the prefabs are just read from the disk and treated as if they were generated by City Builder. So the only phases that happen for those frozen areas are the optimization, spawnification, and LOD generation. And that's pretty much it. That's the way we were able to iterate with the shape of the city for the whole production and then move to a more handcrafted approach towards the end of the process, because we had those persists and freezes, but we kept the pipeline active for the whole time up until this day. So we still had the whole generation running, and we did like the optimization and load generation and all those stuff all the time. We never just like disabled the generation and said, okay, the map is generated, now we modify it totally manually. It was all just part of the pipeline and the process. Now there's a couple of important lessons that we learned from this. So first is that we really needed a semi-procedural generation, not a totally procedural one. So first we tried to create the city just based on the rules, and we hope that artificial intelligence will create a great city for us with a fluent parkour and all those stuff. But we quickly learned that we need just some way to boost procedurally the creation process, hence the name semi-procedural. Then a similar lesson that we actually needed and wanted a higher level of control over the shape of the city than what we initially said. So we really didn't want a generic environment with a couple of unique locations. We wanted control of how the city looks like and how the paths are there. So the initial expectations and thoughts were a bit too optimistic that we won't do that. That's why we needed to implement stuff like freezing by the end. And then the regeneration of everything is quite a long process, and it made like iterating with this not as effective as it could, because after level designers made some changes and if they wanted to share it for others to play, it took about 3 hours by the end of the production to regenerate the city with everything, with LODs. So we were only able to iterate with like a couple of times a day. So without the possibility to incrementally generate it all, it was like really slowing us down. And things should be kept simple. So like limiting the usage of scripts as much as possible would be a good lesson, because like level designers, some still have PTSD after working with those scripts. So yeah, keeping things as simple as possible and limiting usage of scripts for content creators, that's like a really valuable lesson. But hey, after all, we generated Villedor using this approach. There's surely a room for improvement, and we definitely will improve our tools. But you know, millions of players already found their way to the city. If you haven't tried it yet, I encourage you to play and see for yourself, now that you know how the city was built. Thank you.
Thank you, Łukasz. And guys, if you have any questions, please feel free to ask them. Come down here and use this microphone that I will put here and ask the questions.
This one is muted? No, okay.
How big is Villedor comparing to Night City?
I have no idea. Like, no, literally, it's hard to compare, and I wouldn't like to do this, because it's a different level of detail that makes them different to compare. Because as I mentioned, we can climb every of our buildings and like enter most of them. In Night City, the design was like completely different, so I would say they are incomparable to each other.
Okay, thank you.
Did you have any problems with kind of bugs, like for example the generator created some places that, for example, a player could fall off the map or something like that?
Of course, all the time. But you know, we iterated with the generation methods and we invented some manual patching means. So you know, we had like a lot of testers to work with that. But there were a lot of holes, of course.
Thank you.
Any more questions?
I noticed that you have you had like a little bit of overlapped buildings, maybe.
Yes.
And I just wanted to ask, did you handle it manually, or you patched it?
I know what you want to ask.
Okay.
So our corners had like a special feature that we called firewalls at the beginning. So there were like a thick wall that is part of the building that can go in and out of the building. And this way we had like, let's say, infinite number of combinations that we can have because those can move. Then we changed this a bit. It was not a wall because it looked good on the prototype, not so good in the final game. So we had stuff like our buildings were designed in such ways that they can have, like, for example, part of the road or a backyard that can move and just slide under the building. So they were like designed this way to cover those, you know, a couple of meters of the shift.
Thank you.
Please don't bow to the microphone.
Do you think you could generate each patch a new city, so that is the difference?
Sorry, can you repeat the question? I didn't get that.
Do you think you could generate a new city each patch, for example, so that is different?
Yeah, totally. Like iterating with this and generating new city, like completely new city, would be a very easy thing to do. What's difficult is adding like quests, story to it, and that's the part that really takes time. We're not really limited by, by the number of combinations we could have or the size of the city, but actually making a game in it. So, yeah, we can generate many different cities using this method right now.
Okay, thanks.
I got a question about the reason for freezing the buildings. What was the most important reason, thing that couldn't be described in scripts that forced people to freeze stuff and do manually?
Okay, so there were a couple of reasons. I would say the most important one was that they wanted to change like a specific instance of a place on the map, like, make a hole in this certain wall because a quest needs to go there. So that couldn't be described in scripts because scripts give you like rules how buildings are created. They don't care where exactly, in which instance. They just tell you how to populate the city. So this tweaking of single places, I would call it the most important reason. Another one was that we really didn't want to end up with, like I mentioned, any changes in the city if we changed something in the code. So, we have the city, we released the game, then we change like a random number generator and we end up with a different city. So that would be a disaster.
Yeah, sure. Thanks.
Hi, I have a question that's probably maybe under NDA, so if you feel not to answer. But I noticed that you even used the Elysium map that was cut out of the game as an example at some points. The one with this round thing in the middle. Yep, I'm observant.
It's even under NDA.
Okay, but okay. So I'm just I'll ask the question anyway. And then you can confirm it under NDA. Basically, there's a speculation over the internet that this map will be in a DLC. So I just wanted to ask if there is still hope, or we should just forget all hope.
It's classified.
Okay, I have my answer. Thank you.
Hi, I have a question. So I assume that if you have those network of streets and the city generator defines the shapes of buildings, and if you have scripts that kind of tell where the gateway is, where are some different parts, we've seen the screen that there are just like at the bottom layer there is something, and then other kind of architecture goes up, and then around third floor there is a change and some kind of balcony. So do I assume well that once you have taken care and prepare a set of scripts to, let's say, populate 1 kilometer square with content that you really like, you can kind of go wild and generate some extra dodgy ends of the city that are not really took that much care and effort of artists. Yes. That is just something there that generators spit out, and it's not that good, it doesn't have any quest, but it's pretty much okay.
Yes, exactly, and we even end up with something that was quite fun to play. I mean, you could parkour in that spaces, and they were correct. We just, didn't have any quests and unique stuff in them, so that was not the type of game we wanted to create. But yes, the generator is totally capable of making something like that.
So you had to create with extra tasks in Jira around 80 or 70% of the space explorable?
Yeah.
Okay.
First of all, thanks for the speech. It was very informative. And I've got one question. If I got you right, you said that at the moment of generating LODs, there were some manual work. So you wanted to say that the prefabs that were created, there was later on manually adapted and geometry merged,
yes.
or there were some geometry merging made on the generator side?
It was like done in a couple of steps. The thing is, artists created manually just like the meshes that were then merged, and those meshes could be like created for higher levels of hierarchy, not just mesh to mesh, but they could be created for like an entire building. We didn't do that because it would make iterations really slower, but that was the part that 3D artists had to fit the system with some LOD shapes that the merger then took and created geometry and textured.
Okay, thanks.
Last question.
Okay. Okay, last question then. I was wondering, because you, basically talked about generating the outside and the world and the city. I was wondering if you used maybe similar systems for generating the interiors of the buildings, or was that more handmade or pre-made?
Interiors were pre-made, so when you have the building prefab, it can have interior that is designed specially for this building and can be enabled or disabled by City Builder, but it had to be created by level designers and level artists, so the interiors were totally handcrafted.
Okay.
For certain prefabs.
Okay, thanks.
If you have any more questions, you can just catch me on the TECHLAND booth. Right now I will be available there for some time, so just feel free to come and chat. Thank you very much.